Okay, this is the at-home work for Wednesday, the 21st of October. You got page 162, 9 to 17 odds, and this whole section 2.5 is over zeros of a polynomial function. So the first part of your homework says find the number, determine the number of zeros of the polynomial function. So all you do is you look for the largest exponent. So for this problem, number 4, or for number 10, the answer is 4 because the biggest exponent is 4. For this one, number 12, the answer is 6 because the biggest exponent is 6. And for number 14, now this one's a little tricky because when you multiply this thing out, this becomes t to the 4th minus 2t plus 1. And then minus, and you multiply this one out, becomes t, I said t to the 4th, that's t to the 2nd, sorry. T to the 2nd, and over here, when you multiply this one out, you get t squared plus 2t plus 1. In case you don't remember, you square the first term, you take the first term times the second term times 2, and square 1. Same thing here, square t, first time t times 1 times 2 is 2t, and 1 squared is 1. And now we have to distribute the negative sign, which changes this to a plus, makes all these negatives. Okay, so when you now add like terms, t squared minus t squared is 0. Negative 2t minus 2t is negative 4t, and 1 minus 1 is 0. So since this power is t to the 1st, that means there is 1 0 there. So number 10 is 4, number 12 is 6, number 14 is 1. Down here on this one, it says, using in exercise 15 through 18, use the rational zero test to list all the possible zeros, then verify that zeros of f are shown. Now, if you looked in your book, the p, this rational zero test says p over q's, all of the positive p over q's, positive and negative p over q's, are going to be your rational zeros possibly. And the p are the factors of the constant. That means no variable. And then q is the factors of the leading coefficient. That means the coefficient of the variable with the biggest exponent. So when I look at this negative 2, this is the p. So the only factors of 2 are 1 and 2. When I look at the biggest exponent, which is 1, there's the number 1 in front. That is your q. And the only factors of 1 are 1. So when you do all of your p over q's, you put this 1 over 1, because the p is 1, the q is 1. And then you put this 2 over 1. And then if you can simplify them, you do. So the only possible factors are positive, negative 1, positive, negative 2. So these are my possible rational roots. Rational means numbers that can be written as fractions. So you can write these over 1, so these can be fractions. So if you look here, there's an answer right there, which is at negative 2. Do we see that negative 2 is a solution? Negative 2. There's an answer right there at negative 1. This is another 0 right there. So negative 1, there's negative 1 is a solution. There's a solution right here at 1. So positive 1 is also a solution. So as you can see, all of the three real solutions come out of these 4 possibilities. The only one that did not really work was the plus 2, but it is part of the rational solution. So this rational zero test gives you all possible numbers that can work. Oh, I wasn't supposed to do that one. That's your homework problem. Looking at this one, your p factors are 16. The factors of 16 are 1 and 16. 2 times 8, and 4 times 4. Those are your possible p factors. Your q factors, again, there's a 1 there in front of the biggest exponent is 1. So that means all of these over 1. So your p over q's are equal to positive negative 1 over 1, which is 1, positive negative 2 over 1, positive negative 4 over 1, positive negative 8 over 1, and positive negative 16 over 1. So if you look here, there's my first 0. That is a negative 2, which is right there. My second 0 is a positive 2, which is right there. My third one is +4, which is right there. So I'm showing the actual zeros are in here. 18 is the last one I'm going to do. Again, P is this one. So the factors of 2 are only 1 and 2. And then the Q's are 4. The factors of Q are 1, 2, and 4. 1 times 4 is 4, 2 times 2. So now I got to take and put 1 and 2 over all of these. So your P over Q's are going to be positive, negative, that 1 over 1. Then positive, negative, that 2 over 1. Then positive, negative, this 1 over 2. And then positive, negative, this 2 over 2. And then positive, negative, this 1 over 4. And positive, negative, this 2 over 4, which reduces to 1/2. Now, if you look, we got some that repeat here. Because this number right here is 1, and this is 1/2. We don't have to write down the repeating ones. So my possible rational roots are positive, negative 1, positive, negative 2, positive, negative 1/2, and positive, negative 1/4. So if I go over here and look at these, this one right here is -1, which is right there. This one right here is -1/2, which is right there. This right here is positive 1/2, which is right there. This is positive 1, which is right there, and that's positive 2, which is right there. So you can see all 5 of the, oops, I forgot this one, which is, oh, I did say positive 2, I think. That was positive 1, positive 2. So we have all of these, all of the answers that work are down here. Now we got some extra ones here, but these are the possible ones that work. So that's what your homework looks like at home, people. So I will see you later.